Hey friends, you're watching BrainStormAcres. I'm Henry. Today I'm going to talk about Salanova and patents. We had a great comment on yesterday's video. There was a question about, I'm wondering how Salanova can be patented. We'll talk some about that. Without being GMO, another developer can end up with a crop having the same traits without ever trying to copy Salanova. Well, all of that's true. But let's step back and look at how seeds and cars and chairs and airplanes can all be protected by intellectual property law. Now first, a little bit of my background. I've spent more than 20 years managing patent portfolios for a bunch of big companies and a bunch of startup companies. I'm also a patent holder on about a dozen US patents and probably somewhere around 40 foreign patents. I've testified at trial. I've worked with a lot of attorneys on patent matters. I've broken patents. So I know a little bit about the way patents work and why they work the way they work. I'm not an attorney. Don't take anything that I say as any kind of legal advice. If you need legal advice, go talk to an attorney, and specifically go talk to a patent attorney. They're very specialized. They need a lot of unique knowledge. That's not me. So let's talk about how people can protect their intellectual property. Well, what's intellectual property? It could be the logo for your company. Did you know you can get a trademark on that? That's a form of intellectual property protection. If you have a booklet that you've written, you have a copyright on that booklet. You may not know it, but it exists. As soon as you started writing, the words that you put down have a copyright that go with them. Now, if you need to assert that copyright against somebody else, that is, go after somebody because they're violating your copyright, you need to have it registered with the government so that you can actually get some what's called punitive damages. That is, somebody did something bad and now you get some kind of compensation for what they did to you. Then there's the category of patents. Now, there's a couple of different kinds of patents. One's a utility patent. That's what you normally think about. I design a new kind of tire for a car, and I patent that tire. That's a utility patent, most likely. If I've designed a car, and I like the shape of the car, and the shape of the car has very little to do with its functionality, I can get a design patent on that car. Now, there's a lot of nuances and a lot more detail that go into these kinds of descriptions, but let's use this basis to start talking. Well, how did Salanova get patented? It's a very, very interesting question. It's not one that people really think about a whole lot, but somewhere, somebody had to go find a plant that had some specific characteristics. Well, it turns out in the early 1990s, a couple of plants were found in a lettuce field that had some unique characteristics. Well, the first characteristics were having improved resistance to aphids. The question, obviously, is why did they have that resistance? It turns out that in the 1990s, there were a whole bunch of tools available to biologists to study plant cells and animals and how things worked. What they discovered, that there was a very specific gene that controlled how the resistance happened. Now, there's a lot of technical detail that doesn't matter a whole lot, at least for this discussion, but they discovered that if that gene were in a specific location and it was surrounded by some other pieces of gene, that some good qualities would get transferred to the offspring from that plant. If you ever studied genetics at the basic level, you probably studied sweet pea crosses, you know, the white sweet peas and the red sweet peas, or purple, I guess. And you cross them together and then you get something out. Some of it would be white, some of it would be purple, some of it would be striped, some would be other kinds of reddish colors. That's the traditional approach to crossbreeding plants. You take the pollen from a donor plant and you put it onto a receptor plant. And that's going to transfer genetic material from the donor to the recipient. That's been going on for millennia. That's how all of our agricultural products, at least through the 1950s, were created. You crossed it and you crossed it and you crossed it until you had something that behaved the way you wanted it to behave. In the 1990s, the biology tools were improved dramatically. It turns out that one of the first ways to do these kinds of crosses was from the maize plant, corn. It turns out that there is a specific variety of corn that has what's called a large number of haploid cells. Now, haploid, that means it has half of the genetic material that makes up a normal cell. So haploid, half. Diploid, 2 pieces. So what you're doing is transferring 1/2 of the genetic material from the donor plant to the receiving plant. The nice thing about that maize was that it had a visible marker. The stalk of the corn had a scarlet kind of color to it. It was easy to sort through the kernels to find those that had the characteristics that you wanted to reinforce. That's the haploid piece of the parent, versus the ones that got all the genetic material from the mother. So it isn't true that all of the pollen would be haploid. Some percentage of it would be. Depending on the plant species, it can be from 10 to 15% of the pollen being haploid to less than 1%. Now, how does this all apply to Salanova? Well, the answer to that is when you want to get a stable cross, you really want to be using haploid cell material from one donor to the receiving plant. Why do you do that? Because in 2 crosses, that's 2 generations, you can get a stable plant. If you take the long route, you're looking at 6, 7, 8, maybe more generations. That means that many growing seasons, that's that much more time, it's that much more difficult. So what Salanova did, Salanova is owned by a company in the Netherlands. That company is 90% owned by the founding family and about 10% by the employees. So it's another employee-owned company, which Irene and I particularly like. That company has about 9% of the world's market in seeds. So they're number 4. That means 1, 2, and 3, and you can guess who they are very much larger. Now, the trick to the Salanova patenting is really quite clever. In their first patent that they applied for and were granted by the U.S. Patent Trademark Office, they told you how to go about sorting out lettuce plants according to its qualities, and specifically according to when a very specific segment of gene was in the seed germ. Now, this wasn't modifying any genetics. This was just sorting through to figure out what was there. And by sorting through, they were able to discard a whole bunch of potential seeds that weren't going to give them the results they were looking for. Now, I don't know how they originally created the first Salanova plant, but according to the company, they used traditional plant breeding techniques. That means that they weren't using gene editing. They weren't trying to put a flounder gene into a lettuce seed. They were just using what was there and choosing the pieces that did the job that they needed. Well, that patent has expired, and it expired some time ago. You'd think that that's the end of the patent story. Well, it isn't. The problem is that they developed some new varieties of lettuce, also called Salanova, and they used a technique that's called product by process. And that's part of this first patent that they were granted. Product by process means exactly what it sounds like. They patented a process that's finding these genes, and then they patented the result of applying that process to individual plants. It sounds all very complicated. It really isn't, but it is a bit arcane. So now let's go back and address, if you're a plant breeder and you go off and do the same thing, don't even do the same thing, you get the same results, could you be in trouble? The answer is, if they can prove that you used their method, absolutely. If you can show that this is simply happenstance, probably not. Will the Salanova lettuces breed true? I don't know. I haven't tried. Is there a risk of doing that? Probably not. However, the fact that they continue to develop these seeds and get better and better qualities for disease resistance and yield suggests that if you use their old stock to create new seed, you're not going to be doing yourself or anybody else any favors. Well, I'm sure this muddies the water when it comes to patents and plants. It's really not all that difficult. I'm not taking a position one way or another on whether or not patenting a plant is a good idea. Just the same as I didn't take a position 40 years ago on whether software patents were a good idea. Well, actually, I did take a position then. I thought it was a bad idea. I thought that copyright was the correct protection. Can you copyright a plant? I don't see how. Can you patent a plant? Yeah, sure, it's been done and is continuing to be done. I hope you found this interesting, somewhat informative, and not too confusing. Don't forget to hit like, subscribe, and ring the bell for notifications, because we're going to be back to talking about seeds Monday. Thanks for watching. We'll talk with you later. Bye. And don't forget, keep brainstorming.